This is the video solution to sample exercise 3.10 practice problem A. The problem appears on page 95 of your text. This is a lengthy problem in terms of words. We're given a balanced equation for the formation of ammonia, NH3, from nitrogen and hydrogen. And then the actual problem is two parts. We're asked to calculate the number of moles of hydrogen that are required to react with 0.0880 moles of nitrogen, and then the number of moles of ammonia, NH3, that will form. So let's try to break this down into two parts and simplify much of the wording here. The first part asks us to calculate the number of moles of hydrogen that are required to react with 0.0880 moles of nitrogen. And again, we're given that balanced equation. So as we look at this part of the problem, and I've simplified it here, if we frame things in terms of our balanced equation, we're given 0.0880 moles of nitrogen, N2, and we're going to find out how many moles of hydrogen it takes to react with that. Now remember that the only way to link two different compounds to one another is with a balanced chemical equation that shows the ratio in which those two elements or compounds will react. The conversion factor that helps us link two different compounds is called a mole ratio, and we'll be using that conversion factor here. So if we think about this strictly in terms of dimensional analysis, we're given a value of 0.0880 moles, and that would be moles of N2. We'll set up a conversion factor, and we'll know that in the denominator of that conversion factor, our unit has to be moles of nitrogen. That's the only way that the moles of nitrogen will cancel. We want to find out something about the hydrogen, and it is possible for us to put the hydrogen in the numerator of this conversion factor. The numerical values that go in the conversion factor are just the coefficients in front of these two respective elements from the balanced equation. The equation tells us that for every 1 mole of nitrogen, we need 3 moles of hydrogen. This is our mole ratio, and again, that mole ratio incorporates the coefficients from the balanced equation. Now we're ready to calculate a solution, and remembering that our units of moles of nitrogen cancel, we can find out that we will need 0.264 moles of hydrogen to react with our nitrogen sample. The sample of nitrogen was given to us in 3 significant figures, and as we calculated the answer, it came out in 3 significant figures. So there's no rounding involved in this one. We have our solution. The second half of the problem asks us to think about the 0.0880 moles of nitrogen and now calculate the number of moles of ammonia, the NH3, that will form. And again, we're given the same balanced chemical equation. So I'm going to put this simplification up at the top, and we'll think about this problem in a conceptual way. We know the number of moles of nitrogen that we're going to start with, and we're going to figure out how many moles of NH3. These are two different compounds, and again, the only way to relate two different compounds is through the coefficients in a balanced equation, and we call that conversion factor a mole ratio. In this case, we'll start with 0.0880 moles of nitrogen. Again, we'll set up our conversion factor. We need to cancel the moles of nitrogen, and that coefficient is a 1, so that has to go in the denominator. And we want to find out something about the NH3. That will be our numerator, and the coefficient in front of the NH3 is a 2. So 2 moles of NH3 make up the numerator of our mole ratio. Once we have that set up, all our units cancel except the moles of NH3, and we can solve, finding that 0.176 moles of NH3 are going to be produced from 0.0800880 moles of nitrogen. And this value is again correct in terms of significant figures, so we are finished. At this point, you should take a look at practice problem B that accompanies sample problem 3.10. Check your answer with the values that are shown on page 115 of your textbook.